Well, hi there, boys and girls. We're going to do implicit differentiation and also a little bit more of chain rule practice. And I'm going to show you real quickly what I mean by implicit differentiation. We are used to seeing equations like y as some function of x, pretty straightforward, like y equals x squared minus x plus 2, or like y equals sine of x. This is called an explicit equation. Y is explicitly defined as a function of x. Implicit is where you have x's and y's everywhere, like the equation of a circle. X squared plus y squared equals 16. There's the equation of a circle. You couldn't put that in your calculator. You'd have to solve it for y equals and get two versions, and plug in one y1 and one in the other y2. But that doesn't mean we can't find derivatives and find slopes without doing that. So this is what we're going to practice. We're also going to do some more chain rule practice. So this would be an implicit. It is implied that you could maybe solve it for y equals, but that's not going to be our goal. So here we go. Let's just get started. It's the first question off the 2003 BC Calculus test, AP exam, and this requires you to know the chain rule. So I just wanted to practice this. We want to find the derivative. So y prime is going to equal, we do the derivative of the outside function and we leave the inside function alone, and then we multiply this times the derivative of the inside function. And so this would work out to be e. That's just a little practice there. So here we go with implicit differentiation. We've got an equation here, and we want to know the slope of the tangent line at the point 2, 1. And we are not going to solve this for y equals. Let me show you how we're going to find this derivative. We are taking the derivative with respect to x of x squared plus xy plus y squared equals 7. We're going to be using or invoking the chain rule. So here it goes. The derivative with respect to x of x squared is 2x. That's pretty simple. Now when we do the derivative of xy, we're going to have to do the product rule, and that's going to look like this. The first function times the derivative of the second. Now what's the derivative of y? Well, it's y is some function of x, so we're just going to call that dy dx. And then plus the second times the derivative of the first. All of that right there was the product rule from this. Now let's keep going here. I've got y as some function of x, and so this is the chain rule. This is where this is going to come into play. What's the derivative of y squared? So I've got this inside function being squared, so I've got 2y is the derivative of y squared, but then we have to multiply that times the derivative of the inside function, whatever that is, whatever y is as a function of x. And then we get equals 0, because the derivative of 7 is 0. So we want to find dy dx. That's what this means, the slope of the tangent line at the point 2, 1. Well, I'm going to go ahead and solve this for dy dx, even though you don't always have to. We're going to have everything that has a dy dx term is going to stay on one side, and I'll take everything else to the other side. So this is how that'll look. X times dy dx plus 2y times dy dx is going to equal negative 2x minus y. So what I've done is I've taken the 2x and the y to the other side. Then I'll factor out a dy dx, which will have x plus 2y left over. And then at this point I'm going to divide both sides by x plus 2y, and I will get that dy dx is negative 2x minus y all over x plus 2y. So there is our derivative. So now we're going to plug in the point 2 and 1. 2 in for x and 1 in for y. So I'll get negative 4 minus 1, which is negative 5, over 2 plus 2 is 4, and it's negative 5 over 4. And there's our slope. Okay, let's do another chain rule practice. I want to find the derivative of f, where f is h of x squared minus 3. So let's first of all find f prime of x. That's going to equal h prime of x squared minus 3. Again, the chain rule says take the derivative of the outside function and leave everything else inside alone, and then multiply this times the derivative of the inside function with respect to x. So now f prime at 2 would be h prime at 1. Notice I just multiplied, I'm sorry, I squared 2 and subtracted 3, and then times 2 times 2, or 4. And so we get 4h prime of 1. All right, let's do another example of implicit differentiation. Here we have x's and y's everywhere. We don't have y as a function of x. So here we go. dy dx is going to equal the derivative of x cubed is 3x squared plus, now I'm going to let that 3 sit there because it's a constant multiple rule, and I'm going to use the product rule on xy. So that will be x times dy dx plus y times 1. That's the product rule on xy. Now the derivative of 2y cubed, where y is some function of x, this is some, if we were to solve this for y equals, we'd have our function of x, but right now we're just going to imply or assume that we could, and we're going to say that our derivative is 6y squared, that's the derivative of the outside function, and then times the derivative of the inside function, whatever that would be. So we'll just call that dy dx equals 0. And so again, I'm going to get everything that doesn't have dy dx on one side and everything that does have a dy dx term on one side. So here we go. I guess I'm going to distribute that 3 first. So I'll have 3x squared plus 3x dy dx plus 3y plus 6y squared dy dx equals 0. So I'm going to leave these two terms on one side. I'm going to go ahead and factor out that dy dx, which will leave me 3x plus 6y squared. And then on the other side, I'm going to take the 3x squared and the 3y. And then we'll get that dy dx, let me scoot this down just a itty bit. We'll get that dy dx equals negative 3x squared minus 3y all over 3x plus 6y squared. Now, I don't see that up here, but that's because we've got a common factor of 3 that I can take out. So we can factor out a 3. I'll get negative x squared minus y over x plus 2y squared. And again, I don't see that up here, except this a has in the numerator, if you factor out that negative, I'm going to scoot up here to the top. I'm sorry I ran out of room. If you factor out a negative, that's how you get a there. So anyway, I will see you guys tomorrow.